Hello everyone, my name is Titian Dragomir, and we're gonna have some fun with conditional types. Well, I hope we are. I'm gonna have some fun anyway. Um, this presentation is going to be based on several Stack Overflow questions that I've answered over the past 8 months or so. I'm just curious, how many of you actually use TypeScript or have used TypeScript or know anything about TypeScript? Okay, so that's a pretty decent chunk. How many of you would like to use it again or consider using it? That's a pretty decent chunk again, so that's pretty good. As long as we're talking about Stack Overflow, I just wanted to show, languages, it's hard to gauge their popularity, but Stack Overflow questions is a pretty decent metric. So if you look at, for example, TypeScript has 2,000 questions per 30 days, in the last 30 days. If you look at JavaScript, for example, it's 20,000. So definitely TypeScript is still very small, but compared to most of the other two JavaScript languages, those barely register. They have like, I don't know, 10 or 20 questions in the last 30 days. So it's definitely the one that for now has caught on. We'll see if that holds out. Okay. Now, again, since everybody's using TypeScript, how often do you use any? Okay, so I see there's some any fan. There's one any fan here.
Actually, how often is any used on the project?
Yeah. So okay. Okay, so basically, from my point of view, the whole art of using TypeScript is to never write any. So if you're writing any, you're doing it wrong probably. And I'm going to show you several features of the language that help us write more type-safe code and help us avoid using any. So without further ado, this is the first question that we're going to look at. So here we have a user who has an interface, right? Very simple interface, and this basically an interface can enforce the fact that when we assign an object literal, we have all of the properties, right? And now he has a certain use case where he wants some of these properties to actually all of these properties to be optional. So obviously you can write the whole thing again, but if it's a very large interface, that's very convoluted and nobody likes to duplicate all of that. And if you change one, you're going to have to change the other interface. So how can TypeScript help us with this? Well, the simple way to look at it is TypeScript offers a magical type. It's called partial. And if we say partial of any type, preferences, for example, we're going to get a type with the exact same keys, but all of them are not required. So if I were to assign to type my variable as a simple preferences, then I get an error. Okay, you're missing properties. But if I say partial of something, then it's all optional. Okay, well, let's actually take a look at what's partial. So it's not magic, it's not fairy dust. And if we actually go to definition, which doesn't want to work right now. Oh, yeah. We can see that this is actually a type defined in the base library for TypeScript. And we're gonna look at that Elvish script a little bit closer, see exactly what it does, and actually trying to understand and be able to build mapped type, this type of type, which are called mapped types ourselves. How many of you have used map types? Okay. How many of you know how to define a map type?
Like that.
Well. Okay. So let's just copy that in our file here to have it a little bit closer. And let's try to analyze it a little bit. So the first thing we're going to have to understand is this part, this key of T. So in TypeScript, there's a very nice feature where we can actually type a variable or a parameter or whatever to say that its only valid values are the keys of another type. Now this particular v can only be bar or buzz or q. Those are the only valid values. And what you see there is a union type, right? So it can be either of those values. So, and if we try to assign, for example, I don't know, f, that's not good. What if it's forgot my own types, bar? That's fine. Okay, so that's a decent start. We know what that is. Now let's take a look at this whole p in stuff. So let's say we have another variable, and we say that, okay, we're taking all the p's inside something, inside the key of foo. What this means is that basically p is going to be all of the items inside that union. So it's going to be, first of all, it's going to be firstly genre, for example, or singers, or whatever.
What if you only write P in key of foo? What is that?
P in key of foo. Well, if we don't actually write any optional, if we don't have very strict type checking enforced, that's going to be any. And we can also specify it explicitly. So if we say, okay, this is any, right? So every P in key of foo is going to now be, every property in the old type is now going to have the type any, right? So now we've created a new type which has the same keys, but of which we have changed the type, right? So all the keys are of a different type. And for example, you could consider a scenario where you want to validate, for example, that all the values of an interface are valid, and you could return an object which has the same structure, but all of the properties are Boolean. And this could also be an interesting use case, and it would help you type things better. But now we want to say that, okay, it's actually the same type as in the original. Well, how do we do that? Well, TypeScript allows us to actually specify that something is typed the same as the field of another type. So we could, for example, write a new value, a new property, a new variable called value, and we could say that it has the same type as iPreferences of singers, for example. We don't know what that type is, we don't care, it's just we're specifying that it's the same type. If that type changes, the type of this variable is also going to change.
Type and square brackets is some magic to say the type of the key of the thing.
It's called a type query, yes. So you have, this is basically a type annotation, right? And this whole thing specifies that it's not of type iPreferences, it's the singers in iPreferences. Okay, and we can actually take this back to our custom map type, and we can say that, okay, it has the same type as the property p, which we said that p is going to be each property in foo. And it's going to have the same type as the property in the original. Let me just change that to iPreferences because I actually jumped ahead to a different type. Okay. Now there are limits, of course, to what you can do, and TypeScript will check, for example, that the keys match and stuff like that, but that's a different discussion. Okay, so this is great, but now we have actually the same type, so we haven't done much. So what was the point? Well, the thing is that you can start to add modifiers. So, okay, we see that, for example, in preferences partial, the question mark denotes optionality. We can just say that, okay, this property is optional. We could also add a read-only modifier if we want. Read-only. Right? So we can add modifiers and actually change the type. And we could actually, for example, I don't know, return, say that this is an array of whatever thing is there, whatever the type of P is. So we can do all sorts of interesting mutations on the original type. Okay, so now we understand a bit more about how partial works, and let's actually have a look at another question. Yes, go.
Related to partial. So I'm creating, for example, tests, and I'm using partial because I don't want to create a whole object.
Okay.
What about nested properties?
Yeah, you can do deep partial if you want. If you look it up on Stack Overflow, there's actually a question answered on that, and I think there's lots of duplicates of that. So if you look it up, you can say that, okay, T of P is also partial. You can do it recursive.
Another type for each nested level you want to go down.
Well, it's the same type. So you can say, for example, partial of T of P. So we have the same, it's the same type as T of P, only it's partial.
Is deeply recursive?
Yes, it's deep recursive.
So it goes all the way down.
All the way down. It's all turtles all the way down. Yeah, there are some wrinkles here. So this, the why this is actually usually asked on Stack Overflow, and there's been a couple of questions on it, is because this actually works, but it doesn't fully work. There's a special trick to getting arrays to work. You need to treat them specially, because otherwise, and strings and some other properties which you don't want actually to be partial, because you're gonna run into all sorts of strangeness. But yes, you can do deep partial. We can talk afterwards if you want. Okay, so different question. So we have a class, right? And we have certain fields in our class. Okay, and we want to initialize all of the fields. The question asks this with using a special syntax that TypeScript has that allows us to declare fields and initialize them all in the constructor. But we're gonna actually look at an expanded version of that. Right, so what you saw there is basically equivalent to this. And the problem here is that, okay, this is ugly, right? We don't want to pass things like this to initialize. We want to write here, for example, an object, right? And we want to only pass some of the properties, for example. We want here to say 10, right? Or whatever. And how could we do this? Well, we could pass a single parameter, right? And we're gonna just use, for example, object.assign. But now armed with our partial type, how could we make this better?
You could set it as partial of item.
Exactly. So we're gonna say here partial of item. Okay, and that seems really nice, right? We get type checking, for example, if we actually pass a string, it's gonna warn us that, okay, you're not doing it right. But here's the wrinkle with partial. It's all the keys. It's not just the fields, right? So for example, we could actually pass here a method called write, and we're actually overriding something in our class. Probably not the intended use case. We're gonna see a bit later how we're going to solve that. But first, conditional types. And I'm gonna introduce conditional types first of all in a simpler context, and we're gonna look at another question. So basically here the person wants to add some overloads, right? So in TypeScript you can add several overloads, and you can have different return types based on the parameters of the overload, right? Now the problem that this person is having is that actually, okay, if the object it contains true, then that's okay. If the object contains the constant false, that's also okay. But if the object contains something that's actually just of type Boolean, it's not known at compile time whether it's going to be true or false, the compiler won't be able to pick any of those overloads because it's not true, it's not false, and therefore it doesn't know what overload to pick.
Wait.
Yeah, I know, it's a bit mind-bendy.
So there are 4 methods there, right?
No, just one.
4 variants of it.
Yeah.
Okay.
The first 3 are the public ones. There's something called an implementation signature in TypeScript, which is not actually public. You can type that more loosely. And it's not going to be
How does it know
visible.
which one of the 4 is the thing?
Well, so like I said, the
Because it
last
doesn't have a body.
so the last one is the implementation, right? And the other 3 are just overloads, and those are used for method resolution, right? And if we look down here, for example, okay, if you pass it an object with true, then okay, it knows that it has to pick the first overload. If you pass it an object with false,
Which
it
is
would know.
an object.
No. Yeah.
It returns an object with true, yeah, and
Yeah.
with false it returns an array.
The question got to be done the other way around.
Yeah, I had to cut it a little.
No, it says inferred as array where it should say inferred as object.
Yeah.
Oh yeah, well, this is not my context. This is the question.
Okay. But
I did not edit questions, so. Right, and how can we actually make this better? So I'm going to introduce a concept called conditional types. And conditional types allow us to make decisions based on the type known at compile time, based on the type relation known at compile time. So let's have an example. So let's say we have foo, right? And we say, if number extends, sorry, really bad typist, extends string, right? Then the actual type of foo is going to be, for example, Boolean. Otherwise, it's going to be number. Now, I know what you're going to say. Okay, this is ridiculous. I know that number does not extend string. That seems pretty obvious, right? But you might not always know that. For example, let's say that this is not just a simple variable. Let's say that this is in a function with foo. And this function has a type parameter. We don't know what type parameter is going to get passed in. It might be whatever, might be string, might be Boolean, might be, we don't know exactly. Then let's have just an extra parameter that's actually going to be of this type to help out inference a little bit. And now we can say that, okay, if that type parameter extends string, then this type of the second parameter has to be bool. Otherwise, it's going to be number. Now let's just add, finish the method. And now when we invoke, right, we say with foo, if we pass in a string, the second parameter is going to be bool. If we pass in with foo of, what was I extending? Anything else? Okay. Now the second parameter is going to have to be also a number. Okay, so using that we can actually simplify our multiple signatures, right? So okay, we can still have the one that doesn't take any parameters, but if it takes a parameter, right, we can say that that parameter is going to be of type t, right? And what can we say about t? Well, it's going to be true or false, so it has to extend bool, right? Okay, and now we can make the decision. If t extends true, right, then the return type is going to be object. Otherwise, it's going to be an array of any.
Can you put anything there before the question mark?
It has to be a type, but TypeScript has this very interesting concept called literal types. So any constant is also a type in TypeScript.
Cool.
Yes.
Constant. So the number extends 2, number extends 3, number extends 4.
Exactly. So for example, if you say that, I don't know, for example, you have a variable d, right? And you say it's of type, it could be 0, right? Then the only valid value for this is 0. And I know what you're going to say again. Okay, this seems ridiculous. Why is this useful? Well, because you can specify multiple literal types and create a union out of them. You can say that it's 0 or 1 or 2, or actually more commonly, probably it's 0 or 1 or yes or no. And now those are the valid values for this particular variable, nothing else.
You can't have more complicated expressions that evaluate.
No. So basically, the most evaluation you're going to do is with conditional types and with types queries and map types. Those are the things you're going to have to work with. There's actually a very interesting GitHub post. Sorry, I'm going to let you ask the question in a second. GitHub post that actually proves that the type system itself is Turing complete, and you can actually use the type system itself as a programming language, which is not something you're probably going to want to do, but it's fun to think about that as a consequence of this whole recursiveness and this ability to actually play around with types.
It has, if it's recursive and it has conditionals and you can do any way of naming things, then it has to be Turing complete.
Exactly.
So that's literally the definition of Turing completeness.
Exactly. Well, actually, when back in the day when that post actually got written, conditional type didn't exist yet. You can actually do conditional using some other tricks, but it's basically now it's obvious. Yes.
I thought it was before.
That's true. It's a thing which is evaluated to something.
So this is evaluated at compile time.
Yeah, but
so
to a Boolean, if it's either that or not, right?
Sorry.
Yeah, it evaluates to a Boolean.
Yeah, if it extends true or if it doesn't, right?
Yes. Okay. And if it does extend true, then it's object. Otherwise, it's any. So we could have inverted this and said that if it extends false, then you switch it up. It also works.
Okay.
And since t has been already, you have a type constraint here that says that t is only Boolean, you can't have anything else, then this is why this you're pretty sure that the false condition is going to be always when t is false. So there's not much question there.
Can you put 1 plus 1 there?
No, you can't have expressions. Only constants. Okay.
Can you have anything else other than
We're gonna get to an example just in a second that's sure more complex. Extend is it has to be there. But you can extend different things. Okay. One more thing I just want to point out, and this is perhaps a bit more advanced. Actually, if we look, okay, this returns object, this returns any, array of any, and this returns object or array of any. That might seem like intuitively what we'd expect, but this is actually an interesting property of Boolean. Boolean is actually the union of true and false. So if you were to define Boolean, you would say Boolean equals true or false. And conditional types actually, if you have a union, if t is a union, then it will evaluate the condition for each type in the union. So first of all, it says, okay, t is Boolean. Okay, Boolean is true or false. Okay, true extends true. Okay, so we have object. Okay, the other type in the union is false. Okay, false extends true. No. So then we have any, and it creates a union of the two results. Bit more esoteric. Don't worry about it. Okay, let's have a different application of conditional types. So another interesting question is we have a type, and we want to represent something that is a key of the type, but we only want the string keys. We don't want all of them. Too much. We just want the string ones. So how can we do that? Okay. Well, let's have a bit of fun now with another mapped type. So we can say that we take every p in key of foo, right? And we're gonna type this as p, right? Well, how does that work? Well, like I said, p is gonna be each property in each key of foo, because that's what we said we're iterating over. P is also a type, right? Type queries work with literal types, but they work, right? Okay, yeah, that's not valid anymore. So what does this type evaluate to? Well, it's an object that's always gonna have the same keys as foo, but the value is always going to be just the same as the property name, right? So this is actually what you see. There is actually the only valid object for this interface. Okay, that's interesting. Let's also do something else with foo. Let's see if we can get what would be a valid value of foo. What could be one of the values of one of the properties of foo? Any one of them. So it's either string or number, right? Okay, how would we actually get that extracted from the interface and not specified manually? Well, we could say foo, the same type as foo, or of bar, right? Or for example, foo of, well, yeah, that sucks to write, right? Too much. Okay, well, maybe we can write it all in here. Okay, so we say that it's gonna be the keys, it's gonna be the type of those two keys, right? Either or, I don't care which. And then the value is gonna be string or number. But okay, key of foo itself is a union of all of the keys, so we don't have to actually spell out all the property names. That's ridiculous. And we can just say key of foo. And now we're gonna get the union of all of those. And if we change any of these, it's actually gonna update this to be the new thing. Okay, wonderful. Well, now we have here object literal, an object type that has the values the same as the property names. And we could actually get all of the values of this type, right? Using, again, key of foo. And you're gonna say, well, okay, now we're back to the same keys. What was the point of that? Well, now we have an extra layer of indirection, and we can work with that. Because here, we don't have to necessarily specify that the type of each property is the same as the property name. we can use a conditional. And we can say that if the type of that property, whatever that type may be, extends string, then indeed it's going to be P. Otherwise, what do you think we could use? Nothing. Exactly. So it's actually a special type called never. Right? That's never gonna happen. Right? And now, because okay, what did I do? Oh yeah, it's not T, it's type foo. And again, really bad typist. Okay, and now we're just gonna have the key, the string keys of that object. Okay. Now, if we actually take this type and move back to our previous example, right? We wanted here to only specify methods, right? To not specify methods, right? Obviously, we could create a generic type alias for this same as partial, but we're going to just write it here, and we're going to say, okay, if we take all of the keys of item, if item extends, what do you think? Well, method, what are really methods?
Function.
If it extends function.
Then never otherwise.
Exactly. Never otherwise P. And of course, we have to say there key of item. And one more colon. And now we have an error here because this should not have been there in the first place. Well, we still have an error. Can anybody guess why? Because, sorry?
Not optional.
Exactly. We also have to make stuff optional. And I'm still getting an error, and I hope I'm not gonna be. Oh yeah. Actually, there's an extra wrinkle here. We actually P is now just the keys that are not function, and we'd also have to do a bit more to actually make this better. But we can just say here that it's not the keys, it's the type itself, and that works. And I promise you, write will not be valid, although it appears there. There's a way to exclude that as well, but more complicated now, and we're gonna not consume all the time. Okay, interesting questions.
Okay, it says that never, so it's okay.
So you can't assign never to anything to never. So basically you can't, but there's a nicer way to express it, but it would be a bit longer and not necessarily the best use of our time since we're almost at the end. Right. Just one more thing, type transformations, right? So here we see that this person, for some reason, God knows why, has an object field that has several properties, but the actual value is inside an object that has the dollar property. Not sure where he came up with this, but he has it. And he'd like to transform this to something more sensible, like what you see below. Okay, so again, we could use our good old any type, right? We could say here that, okay, we have a function that does this unpacking, right? We could say that it returns Z. But that's not really nice, right? I mean, okay, then R, what can I do with R? I don't know. R dot nothing. Okay, so let's do a first approximation of this. What could be better? Well, we could at least keep the field names, right? So we could say here that P in key of T, it's going to be of type any because it's not going to be of the same type because that's what we're doing, right? And at least now we have something, right? It's a bit better, right? We have email and password, although they're of type any. And again, I hate any, and so should you. We'd actually like to unpack the type, right? So let's look at a simplified example. Let's say just we have one member that has that structure, and we'd actually like to find out what the type of the dollar is, right? We don't know it upfront, right? We can just say that unpack member is the same type as unpacked of type of member. Okay, so we can say that if T extends something with a dollar, right? Then let's keep any for now. Otherwise, we don't care. We shouldn't have that. Okay, but how can we actually get any. Well, we can just tell the compiler to give it to us. So we can just say infer u. And now the compiler, if t has a dollar, has a property named dollar, it's gonna put in u whatever the type of that dollar is. Doesn't matter what it is. And we can say that if that extends is true, then we're gonna have type the actual type of this as u. Otherwise, it's gonna be never. And we can actually use it here, and we can say on back whatever the type of p is. And we can see that actually now email is string and password is number, as we would expect it. I was expecting applause, but stunned silence will also do. It's fine. Okay, so how far can we take this? Well, there's lots of interesting use cases for this. For example, I'm not going to present this because we're already over time a little bit. For example, you can have a class that has an old style API with callbacks and whatnot. And we can actually create one of these mapped and conditional types and everything to actually create a type, automatically create a type that has a promise-based interface. That's one application of it. How far can you go? You can abuse the type system quite heavily, and this is actually a question I answered just a couple of days ago. Great. Technical issues. Oh, am I connected? No, because I'm in airplane mode. You're gonna bear with me just a little bit. Okay, I think. So this is a question. Basically, this guy actually claims to be one of the maintainer of a library. Never heard of that library. It's called Row Class, and he wants to see if there's a way to type his library. And it's actually a library for creating classes. And you can see that they actually use a function called class, which you pass the name of your class, and you pass an object literal, which contains all of the methods, right? Question is, can we type this in TypeScript? And you can see that it also supports extends and other all sorts of interesting features. Can we actually get good IntelliSense for this? Right? First look, I'm guessing most people would say, probably not. Opinions?
Well, obviously, yes.
Well, maybe I'm presenting something that it's actually not okay. So if we actually go to the playground, right, never mind all of that. Don't peek behind the curtain. Okay, we can see that actually here we're going to have to just activate one option because TypeScript is fiddly that way. No implicit this. And we're going to actually see that if we say this, right, inside this thing that's not a class, it's not nothing, right? It doesn't necessarily have an obvious way of knowing that inside this object literal, there's methods of animal available. But still, they are. You can see that bark or make sound, I think, yeah. Make sound comes from the base class. You can do all sorts of very weird type checking and typing in TypeScript, and there's great power in this. You can mess around with it quite a bit. And I know that, for example, lots of you work with all sorts of libraries. Unfortunately, I think most of the library definitions, especially those are of libraries that are not written in TypeScript, are actually stuck somewhere around 6 to 8 months back. 6 to 8 months back, we're talking about conditional types weren't a thing, and maps types were just appearing. So my guess is that it's going to take at least probably another year until libraries actually start using these features, because they're much more powerful in today's TypeScript than they were even a year ago. So thank you very much. You can actually find the code there if you are interested in it. Hope you found it interesting. Any other questions?
I thought you were going to explain how you brought this.
No.